okay, of covalent compounds between two nonmetals, we need to look at page 228, which has the prefixes that we're going to need to use. Okay, so turn to page 228. You need to copy down that book or that table in your book. All right, so covalent compounds are now between two nonmetals. They come from the right side of the periodic table. They're made up of two anions. So we need to be able to distinguish whether it's a compound that's between a metal and a nonmetal, which is ionic, or a covalent compound. So before we start naming these, we need to get this table on page 228 copied down with those prefixes. So now that we know the difference between ionic and covalent, let's do some practice with identifying ionic and covalent right off the bat. Okay, so before you can even name any of these compounds, you need to be able to identify, is it an ionic compound or a covalent compound? Because that stipulates the rules that which you're going to use to name them. Okay, so this first compound, would you say ionic or covalent? Covalent. Why do we say that's the case? Yeah, phosphorus and oxygen are both nonmetals. They're both on the right side of the periodic table. Okay? When we deal with covalent compounds, another thing that we can stipulate with covalent compounds is that we don't reduce our subscripts like we do for ionic compounds. Covalent compounds, you can have P2O2. You don't reduce those. It's a true like bonded ratio. You're not reducing those like we did with ionic compounds. Okay, so you're going to just go with it as it says. This compound right here, is it ionic or covalent? Ionic. Okay, and what's the name? Sodium oxide. Sodium oxide. Okay? Sodium has a +1, oxide has a -2, which is why we need two sodiums. Covalent compounds do not need to be neutral, right? They're both anions, so we can't ever get to a neutral charge. So covalent compounds, you don't have to work so hard to fit them together. You just go with what they tell you. Okay? This one, is it ionic or covalent? Covalent, good. And this last one? Ionic, right? Aluminum is a metal. And this one would be called? Aluminum oxide. Good. Okay? So do we see the difference between ionic and covalent? That's the first thing that you have to do is pick out, is it ionic or is it covalent? Okay? So now let's talk a little bit about some more covalent compounds. We said that CO2 was a covalent compound. What's the name of this molecule? You guys all know it because it's common. Carbon dioxide. Where do we see those prefixes come in? Dioxide. How many oxygens are there? 2. Okay? That's where that prefix come from. So let's go ahead and start seeing how these rules apply to other compounds. Okay? There's some rules for covalence. So we need to go through these rules. I'm just going to put them up here for you. Okay? And then we'll start doing some more practice that goes with them. So here's some rules for naming covalent compounds. So we'll say rules for covalent naming. Okay, the first one is that our element farthest to the left on the periodic table, it goes first. Okay, so when we're naming covalent compounds, it's no longer between a metal and a nonmetal, it's between two nonmetals. So then we have to decide which one gets to be named first, and it's always the one that's farthest left on the periodic table. So whenever we name, we work left to right on the periodic table. Okay, our second rule. So there's our second rule. Okay, says the first element only gets a prefix if there is more than one. Okay, so in the example of carbon dioxide, we're not saying monocarbon dioxide. Okay, we're just saying carbon dioxide. If it was C2O2, we would call it dicarbon dioxide. Does that make sense? The first element only gets a prefix if there's more than one of them. Okay, so if it's a mono at the beginning, you would leave that off. All right. Questions so far about these first two rules? Okay, I'm going to move on to our third rule here then. Do we have what we need from this slide? Okay. Our third rule, the second element gets a prefix no matter what. Okay, so they always get a prefix. Okay, and the way that the second element works is it works like this. We have prefix, then the root of the element name, and then it ends in IDE. Okay, just like our anions did before, but it goes prefix, then the root of the word, then IDE. So the first element keeps its name unless it gets a prefix. The second element goes prefix, root, IDE. Okay, so if I have something that looks like this, if this was the second part of my compound, how would we name that part of it? Trioxide. Okay, trioxide. Okay. And if it looked like this, if our end looked like this, what would we call it? Tetranitride. Okay? Nitrogen's, again, not usually one of our last elements, but it could be. Okay? So it goes prefix, then the root of the word, then it ends in IDE. Okay? And our last rule is really just kind of a spelling kind of rule. Okay? But our last rule says drop the O or A when the root begins with a vowel. Okay, thank you. This kind of avoids us saying tetraoxide, okay, or pentaoxide. Those are no good, okay? We would just say tetroxide or pentoxide or whatever that next word is, okay? That's just more of a spelling type vocabulary thing. So there's our kind of big four rules.
Do you only do that for the A and
What does this look like? It looks like sulfite, but does it have a charge? No, so it's not sulfite. That's where we see a difference, okay? This is called sulfur trioxide. Sulfur trioxide, okay? Sulfite would have a charge of -2. Without the charge, it's not a polyatomic ion, it's just a covalent compound. Okay, so we need to make sure we see the difference there. The charge makes a big difference. Okay? I think covalent compounds are much easier to name than ionic compounds because you literally just spit out what's in front of you. You don't have to worry about charges balancing. You don't have to worry about any of that. You just have to know those prefixes. Okay? So for our next one, right here on our first one, sulfur gets to keep its name because it's the first listed. There's only one of them. It's not monosulfur. It's just sulfur. Trioxide for our second portion. Okay? So for our next one here, what would we name it? Yeah?
Iodide trichloride.
Iodine, not iodide. Okay, iodine trichloride. Good. Iodine trichloride. Okay. Let's try this one. PBr 5. All right, Kiana, what do you think?
Phosphorus pentabromide. Sorry, pentabromide.
Uh-huh. Phosphorus pentabromide. Perfect. Phosphorus pentabromide. It's not phosphide pentabromide, it's phosphorus pentabromide. Okay, so that first element gets to keep its name, right, unless there's more than one of them. Questions here? All right, let's try a couple more. What if it looked like this? All right, Laura, what do you think?
Nitrogen
Nitrogen hexoxide. Okay, so forgot X. Okay. In this case, how many nitrogens are we saying that we have? No, in our Word version, we're only saying we have one, but realistically, how many do we have? 4. So we need a prefix here. Tetranitrogen hexoxide. Just tetranitrogen. Yeah, the first element does not get that IDE. Only the second. Okay? So tetranitrogen hexoxide. Okay? Laura, does that make sense? Why?
Yeah.
Okay, so in case we've got more than one of our first element, that's when we include the prefix. If it's a single, then we do not. Okay? Remember that covalent compounds do not reduce. So this would not reduce down to N2O3. That's not how it works. Okay? They stay just as written. Let's try working backwards here. So if I have carbon tetraiodide, tetraiodide. Yeah, iodide is weird. I think it's too late to change the name now. Okay. Alex, what do you got? CI4. Perfect.